So I just got asked a great question. If matter can never actually fall across the event horizon of a black hole, does it sort of pile up outside of a black hole? Well, this is kind of interesting. A black hole is a black hole because it has extremely strong gravity. So you have the mass of a star when a star's core collapses at the end of its life. Not the sun, but a very massive star. The core collapses, the outer parts blow up, and you get what's called a supernova. But the inner core collapses down, and if it shrinks enough, its gravity goes up through the roof. And eventually, if the gravity gets high enough, the escape velocity from this object becomes faster than the speed of light. Now, the escape velocity is basically how fast something has to move to be able to escape. For the surface of the Earth, that's about 7 miles per second, 11 kilometers per second. The denser an object is, more or less, the higher the escape velocity is. So if you could double the mass of the Earth but keep it the same size, escape velocity goes up. If you keep the mass of the Earth the same size but shrink it down, then it's denser and the escape velocity goes up. And if you keep squeezing it down more and more and more, eventually it gets to be about this big, and then the escape velocity is the speed of light, and it becomes a black hole. Not even light can escape. Now, we also know, through Einstein relativity, that strong gravity slows time down. So if somebody is falling into a black hole, the closer they get to a black hole, the slower their clock seems to tick compared to somebody way outside the black hole. So you and your friend take a rocket near a black hole, and you kick your friend out the airlock. That's some friend you turn out to be. But as your friend falls into the black hole, and he's holding a stopwatch, if you could see that stopwatch, you would see it ticking slower and slower. This is a property of space and time itself. And so basically, you see him getting slower and slower and slower, and when he reaches that point where the black hole's escape velocity is the speed of light, what we call the event horizon, because it's a horizon beyond which you can see no more events, event horizon. When he reaches the event horizon, his clock basically stops. It's an infinite amount of time between ticks. But that's according to you. That's your time. To your friend falling in, his clock is ticking normally, because to him, he's just falling, and he doesn't really feel anything. He's just in free fall, falling into the black hole. He'll pass right through the event horizon. He'll see his clock ticking just normally, and everything will be fine for him. So this all really depends on your, relativity. It depends on your relative position. Well outside of the black hole, you see him disappear basically at the event horizon. So it's not that matter piles up at the event horizon. It's just that you can no longer get any information out from it. According to the matter, it's just falling right through. The event horizon isn't really a special place in space or time. It's just something falling in, so it falls in and it's gone. It becomes part of the black hole. And that's that. So you see this question a lot. Can you ever actually form a black hole if we see its time getting slower and slower? And the answer is yes. According to the black hole, it does actually form the event horizon, and that's fine according to the black hole. And according to us, that event horizon forms basically in such a way that time stops for us looking in. So, a little weird, but the event horizon does form. It has to form for the math to work out, basically. So this all really just depends on your point of view. It's weird. Black holes play with our sense of what's real and what isn't, and what makes sense and what doesn't. But that's why they're fun, right? Besides the fact that they're hugely destructive and just cool. But everything about them is pretty interesting, and there's a lot more you can find out about this kind of stuff, too. In fact, and I'll plug it again, my book is coming out. I have a whole chapter about black holes, and I even talk about them a couple of times because gamma ray bursts form black holes. And then I have a whole chapter about falling in and having one passing through the Earth and all that kind of stuff. So in October, you can get a copy of my book, and you can read all about it. But I'll probably be writing about them in the meantime as well.